Now, as well as having energy diagrams for just straight reactions, we can also have energy diagrams for a reaction mechanism. So if you take a look at the reaction mechanism that I have taking place here, we have Cl2 reacts and becomes 2Cl. That's my first step. Then that Cl that's formed is going to react with carbon monoxide, CO, to produce COCl. The second Cl is going to then react with the other substance that was made, COCl. That's going to produce COCl2. Now, let's just take a moment and figure out what would be the overall reaction. Well, the overall reaction here, if we look, we have Cl, and there's two Cl's on the left, two Cl's on the right. That's a reaction intermediate. COCl gets used up as well. That's a reaction intermediate. The overall reaction here is that Cl2 plus CO is going to produce COCl2. So that's my overall reaction that's taking place, and this is the diagram that goes with it. Now, a few things that we can figure out here. We know that at the start of this reaction, we're going to have our reactants. So we have Cl2, and we have, CO. At the end of the reaction, we're going to have our products. So we have COCl2 at the very end. Now, the first bump that you see here represents the first step of this reaction. So the very top of this first peak is transition state for the first step. And what we can do is actually also look at the activation energy for that first step. So that first step would have this as its activation energy. Now, the other thing I should point out here, it also has its own delta H because it has its own products. So the difference from there to where the reactants are, that's going to be my delta H, and I got to put another arrow here, I just don't have enough room. That's the delta H for step 1. But then we also have another step that is going to take place. And so this next step, at the very peak, we have transition state number 2. We have our own set of reactants here. So I just need to draw another arrow. That is going to be my activation energy for step 2. But step 2 also has its own enthalpy from where the reactants are to where its products are. So that value there is actually the enthalpy for the second step. But as well as that, I also have a third step. So my third step has its own transition state up here. And my words are in the way, but it would be right at the very peak. And from those reactants to the very peak would be activation energy number 3. And we would also have an enthalpy for that step from those reactants to those products. So the enthalpy of step 3. So you can see there's a lot going on here. The other thing that we have going on here is the reaction intermediates. Cl is the first reaction intermediate, and it gets produced after the first reaction is over, which means this little valley is basically this reaction intermediate. This next valley in the second step is its reaction intermediate, COCl2. So in the valleys, we have the reaction intermediates. At the peaks, we have the transition states. We have activation energies. We have enthalpies for each step. But the other thing we should mention here is we actually have an activation an enthalpy for the entire reaction. You see, the difference overall from reactants to products is the delta H of the reaction, just like it was before in other diagrams. But since each state has its own little bump, or each step, sorry, has its own little bump, each step has its own enthalpy. But the overall reaction has its own enthalpy as well. You could actually tell that this would be an exothermic reaction based on what we see here. The other thing is we could figure out what our rate determining step is. Step 3 has to be the rate determining step. And we know that because of the height of the activation energy. It is the largest activation energy of any single step, which means it's going to take the most time out of any of the steps. So it is our rate determining step. So just like any other reaction mechanism, we can analyze a reaction, or just like any energy diagram, we can analyze the energy diagram of a reaction mechanism. We just have to remember transition states, there's going to be more than one. There's one at each peak. There's going to be an activation energy and a delta H for each step, and it's still from the reactants to the products of that step. Reaction intermediates fit into the valleys. The overall reaction has its own delta H, and the rate determining step has the greatest activation energy of any single step. So hopefully this helps you understand how you would set up and analyze a reaction mechanism energy diagram. In our next video, we'll go through an example where we actually draw our own energy diagram. So thanks for watching, and I'll see you next time.